Hello students, welcome back to my channel. In this video, I am going to share Chemistry APSET 2022 paper. Which of the following is not a characteristic of Planck's theory of radiation? Option A. Energy is always associated with radiations. The absorption and emission of energy occur continuously and not in small packets of energy. The energy of radiation is directly proportional to its frequency. The emission and absorption of energy takes place in small packets. So, according to Planck's theory, option A, C and D are correct. So, the absorption and emission of energy occur continuously, not in small packets of energy. That is not according to Planck's theory. So, here option B is the right answer. The atomic number of calcium is 20 and mass number is 40. It contains. So atomic number is 20 means it contains 20 protons and 20 electrons. Coming to the number of neutrons, it is always equal to mass number minus atomic number. So 40 minus 20. So it contains 20 neutrons. So option A, that is 20 protons, 20 electrons and 20 neutrons is the right answer. Which molecule among the following obeys octet rule? Octet rule means it must contain 8 electrons in the outermost orbit for the stability. So coming to the PF5, it contains 5 bonds. That means 10 electrons are present. So PF5 will not obey octet rule. Coming to the option B, NO. NO means it consists of, especially the nitrogen consists of 7 electrons. So it will not obey octet rule. Coming to ClO2, here the ClO2 also contains odd number of electrons. So it will not obey octet rule. So coming to the O2, a double bond is present between the two oxygen atoms and each oxygen atom contains 4 lone pair of electrons. So octet rule is obeyed by oxygen molecule. So option D is the right answer. Which one among the following has higher ionic radius? So whenever if we compare neutral atom with that of cations or anions, cations will have small size than the neutral atom, whereas anions will have large size than the neutral atoms. So sodium will not have large ionic radius. So coming to the option A, B, C, here the ion with greater ionic charge will have greater ionic radius. So option A, that is C -4, will have high ionic radius. 0.2 equivalents of H2SO4 is present in 100 ml of the solution. What is its normality? So 0.2 equivalents are present in 100 ml of the solution. So 2 equivalents will be present in 1000 ml of the solution. So 2 equivalents will be present in 1 liter of the solution means automatically its normality is 2 normal. So option B is the right answer. Which ion is isoelectronic with CO? Isoelectronic means contain same number of electrons. So coming to the CO, carbon contains 6 electrons, oxygen contains 8 electrons. So on the whole, CO contains 14 electrons. We have to verify each and every element. So coming to the option A, Cn minus. That means 6 electrons, nitrogen will have 7 electrons, negative charge means one more electron is present. So it contains 14 electrons. So option A, Cn minus, cyanide, is the right option. 20 ml of 0.01 molar HCl solution is diluted to 100 ml. What is the molarity of the final solution? Here we have to apply the dilution law, that is M1V1 equal to M2V2. So here molarity of the initial solution is 0.01 into volume is 20. And the final solution molarity we have to find it. So M2 into volume is 100. So that implies M2 is equal to 0.01 into 20 by 100. So it is 0.002 molar. And hence option B is the right answer. How many moles of HCl are required to react with 2 moles of sodium carbonate? It is an acid-base neutralization reaction. That means whenever HCl is treated with sodium carbonate, it results in the formation of NaCl plus CO2 plus H2O. So on balancing, 2 moles of HCl react with 1 mole of Na2CO3. So here how many moles of HCl will react with 2 moles of sodium carbonate? So automatically 4 moles of HCl will react with 2 moles of sodium carbonate. So option D is the right answer. Which one among the following is a Lewis acid, also Bronsted acid? Lewis acid means which is ready to accept a pair of electrons. So coming to the option A, B, C, all these C and D, all these are Lewis acids. But coming to the Bronsted acid, the species which can donate a proton is called as the Bronsted acid, and this condition is satisfied only by the proton. That is option C, H plus, is the right answer, which is a Lewis acid and also Bronsted acid. What is the pH of 0.01 molar NaOH solution? So NaOH is the strong electrolyte. It dissociates into Na plus OH minus. So the concentration of NaOH is equal to the concentration of OH minus ions. So OH minus ion concentration is equal to 0.01, that is equal to 10 power minus 2. So it is quite similar to the OH minus concentration is equal to 10 power minus POH. That means here the POH is equal to 2. That means pH is equal to 14 minus POH, and hence it is equal to 12. So option D, 12, is the right answer. 4 alkali metals A, B, C and D are having standard electrode potentials as minus 3.05, minus 1.66, minus 0.40 and 0.80 volts respectively. Which one will be the most reducing? So according to electrochemical series, the element or the metal with lower standard electrode potential will act as best reducing agent. Here when you compare all the 4 values, the metal A is having lower standard electrode potential, and hence it will act as most best reducing agent. Which one among the following is used as the dipolarizer in dry cell battery? So dry cell battery consists of ammonium chloride, magnesium dioxide, zinc chloride, but actually manganese dioxide will be reduced from +4 oxidation state to +3. Here the oxidation state of manganese is 3. So depolarizer means which undergoes the change in the oxidation state. So here manganese undergoes the change in the oxidation state. So option C, manganese dioxide, is the right answer. How much copper is deposited when 2 Faraday of electricity is passed through a copper sulfate solution? According to Faraday's laws, 1 Faraday of current can deposit equivalent weight of the copper. So what is the equivalent weight of the copper? Copper is having +2 charge. So it is equal to atomic weight by 2. When 2 Faradays of current is passed, then 2 into equivalent weight of the copper will be deposited. So the amount of the copper deposited when 2 Faradays of current is passed is exactly 63.54 grams. So option D is the right answer. What is the cell potential for the following cell at 298 Kelvin? Magnesium is oxidized to Mg+2 and copper ions will be reduced to copper. The electrode potential of copper is 0.34 volts, whereas the magnesium is -2.34 volts. So EMF of the cell can be calculated by using the formula E cell is equal to E cathode minus E anode. Here the metal with higher reduction potential will act as cathode. So E copper minus E magnesium. And always remember that the electrode potential should be in reduced form. So standard reduction potentials we have to consider. So both of them are standard reduction potentials, we can use as easily. So 0.34 minus of 2.34. So that is equal to 2.68 volts. So option B, that is 2.68 volts, is the right answer. The hard water sample contains the following ions or salts. Which water sample is more in hardness? So we have to verify each and every answer. Coming to the option D, remember that hardness is not expressed in terms of magnesium carbonate. So option D is eliminated. So coming to the option A, 100 grams of calcium carbonate per liter. That means weight by gram molecular weight gives number of moles. So coming to the option A, it contains 1 mole of calcium carbonate per 1 liter of the solution. So coming to the option B, it contains 50 equivalents of copper. So we have to convert it into number of moles. 50 equivalents means, so equivalents can be obtained whenever the weight is divided by gram equivalent weight. So here the equivalents will be 50. So we have to find out the weight. So that is equal to W by, what is the equivalent weight of calcium? So it is 40. Atomic weight is 40. 40 by 220. So the weight of the calcium is equal to 1000. And we have to convert it into number of moles. So calcium carbonate we have to divide with 100. So we have to convert it into calcium carbonate equivalents. So weight by calcium carbonate molecular weight. So that means on the whole it contains 10 moles of calcium carbonate per 1 liter of the solution. Coming to the option C, it contains 20 moles. So option A contains 1 mole of calcium carbonate per 1 liter of the solution. Option B contains 10 moles of calcium carbonate per liter, and option C contains 20 moles. So definitely option C, 20 moles of calcium carbonate per liter of the solution will give greater hardness to the water sample. 20 ml of hard water required 10 ml of EDTA solution. The hardness of water sample is 1000 ppm. What is the molarity of the EDTA solution? So hardness can be calculated by using the formula molarity of the EDTA into volume of the EDTA into molecular weight of calcium carbonate, that is 100 divided by volume of water sample into 1000. So here we are supposed to calculate the molarity. So that implies molarity is equal to hardness. Here hardness is 1000. Volume of the water sample is 20 divided by volume of the EDTA is 10 into 100 into 1000. And that is equal to 0.02 molar. So option A, that is 0.02 molar, is the right answer. The rate of corrosion is high if. So especially during corrosion, anodic parts will undergo corrosion, whereas cathodic parts will be protected from the corrosion. And the corrosion is severe if the anodic areas are small and cathodic areas are large. So option A is the right answer. The hardness of the water sample is 500 ppm. What is the weight of the magnesium sulfate present in it? Assume that hardness is only due to the presence of magnesium sulfate. So hardness can be calculated by using the formula weight of the substance by gram molecular weight into 100. So we have to calculate what is the weight of the magnesium sulfate. So weight is equal to hardness into gram molecular weight divided by 100, that is equal to 550. Gram molecular weight of the magnesium sulfate is 120 divided by 100. So that is equal to 660 mg, and hence that is equal to 0.66 grams. So option C, 0.6 grams, is the right answer. In electroplating, the metal to be coated or electroplated is made of. So the article or the metal to be coated is always made as the cathode. So option B is the right answer. Which of the following is not a thermosetting plastic? So bakelite, melamine, epoxy resins, all these are thermosetting plastics. So option D, Teflon, is not a thermoset plastic. It is a thermoplastic. Which one of the following molecule contains the functionality 2? So when you consider ethylene, that is CH2 double bond CH2. So whenever a single double bond is present, it is capable of generating two active sites, and hence the functionality is 2. So option D, ethylene, is the right answer. Which of the following is not a synthetic rubber? Buna S, Buna N, and neoprene are synthetic rubbers. So option D, 1,4-polyisoprene, is not a synthetic rubber. Which of the following is not a renewable source of energy? Solar energy, wind energy, hydropower are good examples of renewable energy. So option C, petrol, is not a renewable source of energy. Which one of the following is not a greenhouse gas? Methane, chlorofluorocarbons, and water vapor is responsible for greenhouse effect, whereas sulfur dioxide is not responsible for greenhouse effect. So it is not a greenhouse gas. Which one is responsible for the depletion of ozone layer? Especially chlorine free radical is responsible for the depletion of ozone layer. So option C is the right answer. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.